Hey, how's it going, guys? Today we are going to be going over add two numbers, Leetcode question number 2 in Python. So this is a really exciting question to basically get in an interview because you'll be using singly or singular linked list. And linked lists are a very important data structure because they're often compared to arrays or lists or list in Python. So with access and search, it has O of n time or linear time. So basically, to actually get a particular node or element within a linked list, you have to basically go through everything in order. But the great benefit of using a linked list is actually in inserting or deleting a new item. Now, if you compare it to the performance of an array, it performs better because it's very easy and in constant time to insert or delete. And the reason being is with arrays or lists, once you delete or insert a new element, you basically have to re-index the rest of the array, or basically shift all the elements, or unshift the elements, basically adding one or removing one to the index. So basically just reshifting all elements to um, take into account the new place of that new element. So the really cool thing about this add two numbers is basically you're trying to add two different linked lists. So when you're in an interview, they're going to be asking you to add these two non-empty linked lists, and they're in reversed order. So this actually makes it pretty easy to add this. So, but you should be asking clarifying questions to make sure, because you might not get all this detail. So right here in the input, we see that both linked lists are around the same size, but you also should be thinking about edge cases. So how easy, edge cases. For example, you can ask your interviewer, can I assume that both linked lists are the same size? How you're going to want to write the solution for this is probably just off the bat expect different sizes of linked list. So the cool thing here is we'll be using a lot of different kind of Pythonic or colloquial phrases specific to Python, basic expressions or ways to write Python to answer this question. So it's really cool. And I'll basically be pulling up this graph to kind of provide a visual representation for the solution to this question. So the cool thing here is with a lot of linked list questions, because we don't know off the bat the length of our linked list, instead of using a standard for loop, we'll want to use a while loop, because with a linked list, they have basically two values within a linked list: the actual value of that particular node, and then whatever the next value is. So for example, for one of our inputs, we know that the starting value is 2, and then the next value is 4, and the next value of that is 3, and the next value of that is none. So with a lot of these combinations and removals or deletion problems in linked lists, you're going to want to use what's often referred to as like a dummy node or a dummy head or sentinel, because it just makes it easier to do that kind of these combination and removal methods for linked list. And then also you're going to want to set these inputs to temporary variables. So right here you can see that we set a sentinel that basically is going to be used to easily be our head or starting node in our combined linked list. So because we already have a list node or a linked list class here, we just use that first. So you can call it sentinel, dummy head, doesn't really matter. We have two linked lists that could be the same size or different sizes, set them to temporary variables, and then we basically set another temporary list for sentinel. So remember Python, if you have two variables pointed to the same thing, they'll, like, once you make changes within this while loop, it will reflect back down below, and you'll see with our ultimate output, as we're adding all these additions, we're going to basically be returning this node right here, just minus the sentinel. So again, because we don't know the length of our linked list off the bat, similar to what we would easily do with arrays, we're going to use a while loop because we can't use a for in range loop in Python. Just a quick little reminder too. Uh, um, with while loops, you can use external variables like counters, or maybe using a stack. Like here, we're just because we're using linked list, we want to run through both the first linked list and second linked list and do all possible additions. So right here, until we reach both of these uh, to their none value, or nil or null if you're coming from a different language other than Python. So the second thing I want to point out is here we set temporary variables x and y, and we're using what's called a ternary operator in Python. So basically, all you have to know in the standard formula is the easy way to use a one-line statement instead of having to basically use a multi-line statement to create a new variable. So basically, how you do it is yield this untrue value if a condition is met. So please give me p dot value, or like the first linked list node's value if p exists, so it's not none, else put it as 0. So you can see later on, once one of our linked list nodes ends, that's going to be important. So instead of it being none here, it's going to be 0. So 5 plus 0, then it's going to yield 5 down here. So we just basically do that for x and y. We've also set a carry variable. So if x plus y is greater than, or sorry, if we have a total greater than 10, basically the let's say 12 for example, we're going to carry 2 to the next addition for the linked list nodes. So for the carry, let's say we have 12. 12 divided by 10 is going to be the next carry. And let's see, what we're going to do here is use the modulo operator for remainders. So the cool thing about this is, again, the only thing that's really complicated with this solution is figuring out how to carry numbers greater than 1. So obviously, simple elementary math. Let's say you have 4 plus 6. If you divide that by 10, you're going to get 0, and then you want to carry that number over to the next portion or addition here. So let's say it was 7 plus 4. The resulting combination is going to be 1 here, and then you're going to carry 1 also here because that's the remainder. So I just gave a little example here. The cool thing about the modulus operator is if the number is less, so let's say 2 plus 5, 7 modulus 10 is going to just return that single number. It's only going to create a carry value if it's above the number 10. So basically we're saying this current value, this next value is going to be the result of that modulus operation. So I just kind of do a quick visualization with the graphic I created here. So again, why are we using cur.next? Because remember, when we initially set this dummy head or sentinel value, we set it to the temporary variable cur. So basically what we're just doing in this while loop is every iteration we're doing the next value, or the current value, based on this these series of operations. So let's just do the loop for the graphics. So this first one, we're setting this to the sentinel to cur, and then on the while loop, we're doing 2 plus 5. So 2 plus 5 modulus 10 equals 7. So cur.next. So the next value is 7. Okay, so we got that. And then now cur equals cur.next. So on the next iteration, it's going to be right here. And then we'll add 4 plus 6. That 10 modulus 10 equals 0. And it's going to add 1 to the carry value. But the next value is going to be 0. So again, throughout this whole while iteration till we hit the none value for both linked lists, it's going to do like these operations. So here, again, it's just iterating through both linked list. So for these two inputs, the first linked list P, the second linked list Q, dot next, dot next, dot next, dot next, until both of them reach none. And that's why this OR statement is so important. As long as one linked list keeps on having values or nodes, it's going to run through this carry addition operations and the modulus too. So once you go through and reach the end for both P and Q, you should have a value similar to this, but we also want to have a condition in case there is a carry on that last addition operation where we're adding that carry. So let's just say, for example, we had like 6 and 5 right here. That's going to have a carry of 1. So it would add 1 in between that last node. And then finally, with this iteration, all we do next is we do sentinel.next. So when we actually return the value, we don't need this dummy head anymore. We're actually just returning a fully combined linked list from our two inputs. So basically that's how you solve it. Again, key concepts are, if you don't know the length of your inputs, it's really good to use while loops instead of a for in range loop. You can easily use ternary operators to do kind of single line conditionals and expressions. So if this expression is true, return this certain value. If it's false, return this other value. When you're using linked lists, you often use the while statement and basically just iterate to it until you reach a none value. And then also finally, when you do kind of these singly linked list questions, you're going to want to use dummy heads or sentinels to make it easier to combine or delete or modify two different linked lists. And finally, with this, think about why certain questions are using certain data structures. So for linked list, again, insertion deletion, that performance is a little bit better than arrays. So I hope this question was helpful. Please let me know if you have any questions. Linked lists are a lot of fun, like once you get the hang of it, and it's a lot of fun. So if you can, please like and subscribe to the video. Please let me know what future Leetcode questions would help you better understand certain concepts, and I'll keep on doing these videos. Thanks again, and see you next video.